Welcome to video number 2 on the training topic about KDOT's corridor point naming convention. Continuing the discussion about the benefits of consistent corridor point naming. Specifically with corridor point naming though, there's another really good reason to make consistency a design goal. And it has to do with downstream use of our design models and what contractors are wanting to do with them. So one of the most important features of the design models that we can produce out of ORD, most important to contractors anyway, is the linear features that come out of our corridor designs. The point names are associated with the naming of those linear features, and consistency there is important to contractors because that is the most valuable piece out of the corridors for developing construction models to support their automated machine guidance operations. Typically, contractors aren't going to use a design model directly, but they want to get to the building blocks of the design model because they're very valuable in helping them get started with their construction model development for their operations. And when we're naming our corridor points consistently, that means the linear features are going to be named consistently. And that means that contractors, when they're seeing the same structure, the same format for naming, object naming in the design deliveries that they're working with, that means greater efficiencies in their work as well. So absolutely we're seeing benefits with consistency in corridor point naming in design, but it's also very beneficial to downstream operations and specifically contractor use of our design models. Okay, now that we know why consistent corridor point naming is so important, let's take a look at the naming convention. So I'm in a PDF version of the corridor point naming convention guidance document, and we can see here that the format of the corridor point naming convention that KDOT has developed has 6 information fields. You can see it in bold text here. Each information field is separated by a hyphen. So you see we have 5 hyphens in the structure. These 5 hyphens are always present in all the corridor points that we're going to name. So some of these information fields, we're going to call them identifiers, and some of these identifiers are optional to have a value in a corridor point name. A couple of the fields are required, but several of them are optional. When there is no value associated with a corridor point name, an underscore is placed in the structure of the corridor point name so that we always have the 5 hyphens and the 6 fields visible, and that's going to make it easier for people to read and understand what the corridor point name is describing, as far as the feature that this corridor point represents. It's going to be easier to find the location of each value for the identifiers when we have the hyphens always in place rather than just dropping off the end if there's no value, say on the last couple of fields. It's also going to make it easier for us long-term to programmatically access this information because it creates consistency. We always have the hyphens, and each piece of information is consistently located within the data structure. Note that the geometry feature identifier is broken down into 2 subcategories. We have the major and the minor geometry feature identifiers, and those are delineated by a colon. We'll explain why this is so as we look at the purpose and the content of each geometry identifier. Please continue on to video number 3, where we continue our conversation looking at the corridor point naming convention.